If you have more than one vector, you have to add them together. This is called vector addition. Let's start out kind of small. Say you walk 100 meters to the south, and then turn east and walk another 50 meters. What is your displacement? All right, so the first step would be to draw our vectors. 100 meters south will be a straight line down on our paper. East is at a right angle and another straight line to the right of our paper. As a result, you're going to end up somewhere southeast of where you started. To find the magnitude of your displacement, we can use Pythagorean. The resultant vector is the hypotenuse, which is c in this equation. And the south vector we can call a side, and the east vector can be the b side. Note that you can switch the south and the east, it doesn't really matter. As long as you have the two sides of your triangle and identify the hypotenuse as c, you're going to be fine. So if our a side is our south, we're going to take 100 meters squared. We're going to add that to our b side squared, which is 50 meters squared. And that will be equal to our hypotenuse, c squared. So we're trying to find c, we're trying to find our hypotenuse. So we're going to square root everything that's added together there on that left side. We're going to math everything underneath the square root sign, and we find the magnitude of the displacement to be 112 meters. So the length of our hypotenuse is equal to our overall displacement, and that is 112 meters. Now we know all three sides to our triangle, so to figure out the direction, we can use any of the trig functions that we want. We are interested in the angle that the resultant makes with the south vector, since that is where we started in our coordinate system. If we use sine, it will be the opposite over the hypotenuse, or 50 over 112. Cosine is the adjacent over the hypotenuse, so 100 over 112. Or, if tangent is your thing, you would use the opposite over the adjacent, or 50 over 100. No matter which one you use, you will still get an angle of 27 degrees. So our displacement is going to be 112 meters, 27 degrees east of south. Now, what if we have more than two vectors involved? Here you are traveling north, then east, and then back south. So start with the vectors. Draw them to scale and in the right direction. Drawing our resultant, we see that we end up somewhere to the north and east of where we started. What we want to do here is look at all of the vectors that are pointing along the same axis. We are looking for the x component and the y component of our resultant vector. Let's start with the x component since there's only one vector in that direction to start with. That makes the x component of the resultant 10 blocks to the east. Now what about the y component? We went 20 blocks north and then 18 blocks south. These vectors can be added together. If we define north as positive, that would mean the south is the negative displacement. So a positive 20 blocks plus a negative 18 blocks gives us a y displacement of a positive 2 blocks. Now that we have the x and y components for our resultant vector, we can go about finding the value for the magnitude and direction. So our displacement is 10 blocks to the east and 2 blocks to the north. So now that we have our x and y components for our resultant vector, we can go about finding the value for the magnitude and direction. The magnitude will still use Pythagorean. We find that we are 10.2 blocks away from our starting point. Then again, pick a trig function and solve for the angle. We find the displacement to be 10.2 meters at 11.3 degrees north of east. So here's one. You run 12 kilometers to the south, then turn and run 8 kilometers in a direction that is 30 degrees west of north. What is your displacement? So now we're getting interesting. Again, start with your vectors drawn head to tail. Then we're going to add in the resultant. And then what? Well, we have to find out how far we go in both directions. Since one of our vectors is in the y direction, that one seems pretty straightforward. But then there's this 30 degrees west of north thing. So let's start by identifying which angle is the 30 degrees. Imagine the single vector all by itself. And then imagine making it a right triangle with a y-axis. This lets us resolve the vector into its x and y components. Since we know the angle and the magnitude of the vector, our trig functions can make pretty short work of this. The x component is the opposite side to the angle, so we will use the sine function to solve for it. This gives us an x component of 8 kilometers to the west. The y component is the adjacent side, so cosine is the appropriate function that gives us a y component of 6.9 kilometers to the north. Now we can tackle the problem of the components of our resultant vector. The only vector that is contributing to the x component is the second one, and we just found that the x component to be 8 kilometers to the west. So the x component of the resultant vector is 8 kilometers to the west. The y component is going to be made up of the y component of the second vector added to the first vector. South is negative by convention and north is positive. So we're going to add a negative 12 kilometers to positive 6.9 kilometers. This gives us a total displacement in the y direction of negative 5.1 kilometers, or 5.1 kilometers south. Now we can go about solving for the resultant. Isn't this fun? According to the Pythagorean, the magnitude of our displacement is going to be 9.5 kilometers. So we have our x component 8 kilometers to the west, and we have our y component of 5.1 kilometers to the south. And according to tangent, this happens at an angle of 33 degrees. So our overall displacement is 9.5 kilometers in a direction 33 degrees south of west.